All right, let's do another limiting reactant problem today. So as you recall from our last video, and we talked about this before, and you heard about this in lecture, the limiting reactant can be thought of as what reagent by proportion will run out first in a reaction. So let's go ahead and get into this problem. Now we see in the following reaction, we have 4.68 grams of the NH3 ammonia are reacted with 2.50 grams of oxygen, of O2. So to find limiting reactant, we're going to have to find moles, right? But before that, what are we going to have to do? We need to balance our reaction, definitely. So let's go ahead and balance this thing. I'm going to speed things up a little bit here. You are currently training or have been trained how to balance a chemical reaction. So make sure you're fast for it for the exam. There. Now we're balanced. Go through and take the time to do this, okay? Don't just take my word for it, because you're going to need to be able to do this quickly on an exam. So let's find the limiting reagent. As you recall, the way we're learning it, at least with me, is we're going to find out how much product is formed from this and how much product is formed from this in two different cases. And whichever one forms less product is the limiting reagent. So let's start off with ammonia. And we were given 4.68 grams ammonia. I'm going to go a little faster with dimensional analysis as we progress through the quarter. I'll remember when we're doing dimensional analysis, we're going from grams to moles. We need to use molecular weight, right? And if you forget on your dimensional analysis where things go, what do I always say? Put the thing you want to cancel out on the bottom. Right, and then you just need the molecular weight. And I'm kind of using whole number integers there. All right, now we're in moles NH3. Now we need to go to what? Moles product. So we need a molar conversion. Now I'm just going to pull those proportions. So I'm writing moles NH3, and I'm putting that at the bottom because we're now in moles NH3 up here. I know I need to cancel out moles NH3, so I put it down there. Now I know I'm converting to moles product, so I put it up top. And now just write the numbers from the equation, the coefficients from the equation. And it's 4 to 4, but it ends up being 1 to 1, okay? We still got to go through that step. Make sure you show that step when you're showing your work as well. So now that we're in moles NO, now if we're to go from moles NO, now I'll tell you, you can stop there and get moles, but we're going to continue and get grams. And you'll see that'll pay off later. You don't have to do it this way. So for every mole NO, how many grams do we have? Just add the atom, the masses of the atoms together, N being 14, O being 16. Let's call that 30 grams. And now we're ready for some grams NO amount, right? Punch that into your calculator. 4.68 divided by 17, enter. Times 30, enter. And I got this long number. I'm not rounding yet because we don't round to the end, so I'm just writing out all the numbers from the calculator. Here we go. So now let's use the other species to find out how much product is formed from 5 moles of oxygen. So we were given 2.50 grams of oxygen. Its molecular weight for 2 oxygen atoms is 32. Now that moles O2 is on top here, now moles O2 is going to be on the bottom. And now our moles product will be on top. And then just fill in the numbers from the equation. Fill in the number from the coefficients. So how many moles NO? 4 moles NO for every 5 moles oxygen. Boom. And after that, we know all we need is the molecular weight. I'm going to draw a line to separate these two. Sorry, they are squished. There we go. Now, what's that last number? It's the molecular weight of NO, which we already have. So for every 1 mole NO, we get 17 grams. Oh, sorry. Make that 30 grams. 30 grams. Because it's NO. There we go. All right. Now let's find out what that number is. So again, we'll go 2.50 divided by 32. Right? And then I would do like a times 4 over 5 in parentheses, or you can just go times 4, enter, divided by 5, enter, and then times 30, enter. And you end up with 1.875 grams NO. So now, also you could compare moles for the same thing. Since they're both in NO, grams NO at this point, we can compare grams as well. Okay, but if they're different elements, we can't compare them by grams, right, due to their molecular weight. But in this case, it looks like we have 8.3 roughly grams of NO in the first case, and then in the second case with O2, we got 1.875 grams NO product formed. So definitely there's less product formed with O2, so that's our limiting reagent is O2. So what is the limiting reagent? We'll say O2 is limiting. Right? And then we see we've kind of already answered the second question. And that's one good way about doing it. How many grams of NO are formed? Well, you couldn't certainly write 8.23 grams or 26 grams, right? Or 8.3 grams, whatever that ended up rounding to, because that's our excess. That's based off our excess reagent. So since the 1.875 came from the moles of oxygen, right? We can use those grams NO formed from that because that's the limiting reagent. So it ended up being 1.875 grams NO. Okay, you just use the grams of product formed from the limiting reagent. Now, how much of the excess reagent remains after the reaction? So to do this, we know that only so much of this NH3 ammonia, we know that that's excess. So inherently, that means that some of it was used to react with this O2, but not all of it. So now let's calculate how much NH3 was actually used. And we do that by converting this 2.50 grams O2, the limiting reagent, to grams NH3. So let's start that off. So we'll start with 2.50 grams oxygen, like that. And then we need to convert it to moles. So what do you need for that is molecular weight. And since you start with grams, put grams at the bottom per 1 mole O2. Now molar conversion, right? Molar conversion. So just write what you need to cancel out at the bottom. So since we're in moles O2, that's going to go at the bottom. And then write what you want on the top, which is NH3, moles NH3. And now just use the chemical equation to write the coefficients here. So for every 4 moles ammonia, we had 5 moles O2. And now we're in what? Moles NH3, so let's convert to grams now. Since moles NH3 is up above, now we're going to put that on the bottom. For every 1 mole, we have how many grams NH3? So we need grams used. That was 17, right? Now let's find out how many grams that equals. And I ended up getting 1.0625 grams ammonia reacted. And again, to do this, you put 2.50 divided by 32, enter, times 4, enter, divided by 5, enter, times 17, enter. Or 2.50 divided by 32, enter, times, in parentheses, 4 over 5, end parentheses, times 17, enter, times 17, enter. Okay. Just trying to help out there with being able to manipulate your calculator to do these problems too. Sorry, I know some are already familiar with that process. Others are not necessarily. So that's how much was reacted, but we know from the prompt that we started with more than that, right? You see it, it's 4.68 grams NH3. They told us that we started with, but we didn't use all that. We actually only used 1.0625 grams. So let's subtract what was reacted from the total that we started with. So there we go. We're going to take the initial amount, subtract out what was used, and I got, make sure you check these numbers in case I did something wrong here, right? Don't just take my word for it. And it helps practice on your calculator. Just get used to this stuff. So we actually had 3.6175 grams NH3 excess now. And that was what was remaining. So for 2.50 grams O2, we only needed 1.0625 grams NH3, not all of that 4.68 grams that we started with. One last question. Now we're asking the question, if the actual yield of NO is 1.5 grams, what is the percent yield? So percent yield, let's try and recall what that is. If you haven't heard it, we're about to find out. So your percent yield will be your actual yield over your theoretical yield times 100. Actual yield over theoretical yield times 100. So in this case, we have this number. We said the actual yield was 1.5. And what was our theoretical yield? We did calculate that already. So your theoretical yield is what happens if 100% of the reaction goes to completion. And so in this case, with that 2.50 grams oxygen, if it all went to completion, we would have got 1.875 grams NO. So please allow me to move this back here for you. There we go. Just going to take 1.5 divided by 1.875. And then you'll definitely want to multiply that by 100 for a percent. Okay? And what I ended up getting is 80% in this case. Okay? So piece of cake, right? If you practice this enough, this starts to come to you really fast. All right? There is another way to calculate limiting reagent. You're free to use that. You may learn that in lecture, and you may not learn this particular way in lecture, and that's okay. All right. Hopefully you find which method works best for you. So good luck studying this stuff as always. Keep an eye out for more videos. Take care.